Hey, Dan sent out papers from the Humongous Book of Statistics. First of all, I want to tell you guys how lucky you are to have an engineer teaching this course and not a mathematician. They can make the most simple things look complicated, and much less give them a problem like this. Oh my goodness. So anyway, here's the problem. A company claims the average time a customer waits is less than 5 minutes. A sample of 35 customers had an average wait time of 4.78 minutes. Assume the population for wait time is 1.8 minutes. So what we got then is a average. It's equal to 4.78. The sample size is 35, and standard deviation is 1.8. So the way we do this, again, we're going to use the central limit there. We're not going to use the standard deviation since we're dealing with a sample. So we're going to use the standard deviation of the means. And that's simply the population standard deviation divided by the sample size. So we get 1.8 divided by the square root of 35. Calculate that all out, we get 0.3043. And if we take our point of interest at 5, we come in, or 4.8. So I'm going to do the norm dis in Excel. I'm going to put in 4.78, 5, and instead of using standard deviation, I'll put in standard deviation of the means and true. So this will be, what's the probability of getting 4.78 or less by random chance? Assume that the population standard mean is 5. You crunch all that in, you get 0.234849, or another way of putting that is 23.48%. So what we're saying here is there's a 23.48% chance of getting 4.78 or less just by random chance. So the significance, again, we talked about this. This is the probability of a type 1 or type 2 error. They're saying it's 0.05 or 5%. You got to be less than that to make sure that there is a significant difference. You can see we're well above that. So then we would just reject the, fail to reject the null hypothesis and say this really isn't enough of a difference to support the claim.